Next, I'd like to show you how to use the calculator to evaluate some logarithms. And I want you to notice on a graphing or scientific calculator, there are logarithm buttons. The two logarithm buttons that you'll find on the graphing calculator, this is a TI-83, 84s are very similar, are the LOG button and the LN button. The LOG button is log base 10 and the LN button is the natural logarithm. Those are the only two logarithm buttons that you'll find on either a scientific or a graphing calculator. They are the natural log button, or we'll say LNX, which remember is log base E. No one writes it that way, but just as a reminder. And the other one is the common log. And the common log we say is log X, or don't forget that there's an invisible base 10. Those are the only two logarithm buttons that we have to use on our graphing or scientific calculator. There are no buttons for any other bases other than 10 or E. So if you need to estimate a logarithm in decimal form with a different base, then you need to use the change of base formula. And the change of base formula will change your base into any other base that you choose. But for the purposes of estimating or using our calculator to get a decimal approximation, we would only want to use one of two bases, either base 10 or base E, because those are the only two bases that our calculators have programmed into them. So the change of base formula says log base B of M is equal to log base any other base you can think of with an argument of M divided by log base A of B. Notice B was the base, now it becomes the argument with any other base that you want. And that's the general form of change of base formula. I'm going to go ahead and add a little bit more here. I want to emphasize that a common log you could choose is the common log. So we have log base invisible 10 of M divided by log base invisible 10 of B. This is a good choice because we have a common log button on the calculator. We also have the natural log, so I could take ln of M divided by ln of B. So we could choose any other base we want. And that's A, any base we want. Notice there is no A in the original problem. A could be anything you would like. Or we could use the common log. Or we could use the natural log. So we have three examples for you here, and I want you to estimate log base 5 of 140, log base 4 of 15, and log base 2 of 100 in your calculator. So we know our calculators are not programmed to calculate base 5 logarithms. Because we only have an LOG button or an LN button, we're going to be changing our base to either base 10 or base E. To change base 5 into base 10, we'll use the common logarithm. I have the quotient of log of the argument, 140, divided by log of the base, 5. Notice I'm using common log here. Once I've changed the base, now I can open up my calculator and just type log 140. Notice it opened up a parenthesis, so I'm now going to shut the parentheses, divided by log, open a parenthesis, 5, close your parentheses. When I hit enter, it gives me an approximation of 3.07. And we'll approximate to the hundredths. Now I want you to understand that you could do this whole problem again, and instead of using LOG, you could use natural log. ln 140 over ln 5, using the same change of base formula, using the natural logarithm instead of the common logarithm. Now I'd like to type that into my calculator and see what answer I get. So this time I'm using ln of 140 divided by ln of 5. Hit enter, and look at that. You can see both of these answers here are exactly the same out to as many places as we can see. The answer is still 3.07. Does it really matter which way you do it? Well, the answer is no. But you do need to either choose natural log or common log. Any other base won't really help you when you're trying to calculate using the calculator. Next, I'd like to approximate log base 4 of 15, which can be either rewritten as common log 15 over common log 4, or I could rewrite it as ln 15 over ln 4. One way that just helps me remember that the 15 goes in the numerator and the 4 base goes in the denominator is because the argument 15 is already located physically higher than the base. I know that's a really kind of a bad analogy, but because the 15 is already a little higher, I remember to put the 15 in the numerator, and because the 4 is already a little lower, I remember to put the 4 in the denominator. That is not mathematically sound. That's just a mnemonic device to help me remember which one goes in the numerator and which one goes in the denominator. So let's pull out a calculator again, and this time we're going to type log 15, close my parentheses, divide by log 4, close my parentheses, hit enter. I'm getting 1.95 rounded to the hundredths. I could approximate using ln. It should be the same answer, so that's one good way that you could check your work, is just to type it in with both log, the common log, and ln, the natural log. And I get the same answer, 1.95. Do you really have to do this twice? The answer is no. You do not have to do this twice at all. On the next one, I'm just going to go ahead and do ln. That's the one usually books prefer to use. We said the natural log is the most preferred of all bases, so I'm just going to go ahead and do this once this time. ln of my argument, 100. Remember, the 100 is already a little higher than the 2, so that reminds me that the 100 goes in the numerator, and the base was already a little lower. He goes in the denominator. Not mathematically sound, but it helps me remember. Take out my calculator. Let's clear out what we have here and write ln of 100 divided by ln 2, which gets me 6.64. And that's how we approximate logs of any base. So in summary, the 4 properties that we learned in this lesson are the product rule, which gives us when we add 2 logarithms together, we get log of that same base, and we multiply the 2 arguments. If I'm subtracting 2 logs, I can rewrite that as log base b. Notice the bases have to be the same, of the quotient of the 2 arguments. Because it says subtract, I take the quotient. The power rule allows me to move the coefficient up into the exponent to get log base b of m to the p. And lastly, the change of base formula tells me that I can change my base b into any other base, usually for the purposes of calculating it on a calculator using the common log or the natural log. But I could, in general forms, write it log base anything you want, we'll say a, of m divided by log base anything you wish of the original base b. We will use these properties in the next section to solve logarithmic equations.